everyone, welcome. I'm your host Serap Çevirgen. Today, I would like to talk about climate change. I know pretty much everyone knows about what is climate change, but I would like to talk today with the data and give you some scientific background so that you can reason yourself and you can understand really why it is happening, how it is happening, what's the degree of it, trend of it along the history. Because I believe once you understand the root causes, you can act much more decisively. So, whoever you are, just a person trying to reduce your CO2 emissions, or maybe you are a business owner or you are a government representative, I believe this is going to be very helpful for you to understand the dynamics of climate change. We are not going to go into technical details, however, we are going to understand it. Okay, so as you may imagine, when we are talking about climate change, rising temperatures, we are talking about greenhouse gases. So these gases are actually naturally present in our atmosphere, and actually we need them because they have, as the name suggests, greenhouse, they have a heat trapping effect. And thanks to them, actually, our planet can support life in any form. So it is okay when they are naturally present in their concentrations, but the problem is stemming from us because we started emitting greenhouse gases, especially carbon dioxide being the most, but also other greenhouse gases like methane, fluorinated gases, nitrous oxide, etc. And they reached in a level that they are really trapping the heat. And since this heat is trapped in our atmosphere, average global temperatures are rising. So, I would like to show you a figure from NASA, and so that you can understand the historical concentration of CO2 in our atmosphere, how it evolved, and what is the level today. So, let me find this. Here it is. So in this figure, you can see on the horizontal axis 800,000 years of data showing us CO2 concentration. As you see, there are peaks and valleys in this figure. And if you pay attention, you can see that every 100,000 year is a cycle. CO2 concentration goes up and then down and then up and then down. So when it is peaking higher, the CO2 concentration, the temperatures are warmer. When it is in the hollow part, these are suggesting ice ages. Okay, in this graph, you see that it is oscillating between how it is around 160, 180 ppm to 260 ppm or 280 ppm, right? So it is always under 300, and we have this pattern naturally. And then comes the time 1950, and we see that it peaks. There is an instantaneous jump there. Of course, don't forget, this is 800,000 years of timeline. So in this geological time scale, these years, these decades from 1950s till today, it seems like an instance. However, there we are having around 65, 70 years of data. What is interesting is that this jump, that it reaches around 420 ppm, parts per million, it's just another measurement unit for the carbon dioxide, right? So it reaches this level that it was never there before. I mean, it really jumps. So what has happened? Let's try to understand with the data what caused this jump. Actually, let's try to reason it right now ourselves, because we are talking about pretty much a century or a century and a half here. As you know, it happened industrial revolution, right? end of 1800s, beginning of 1900s, we started to produce, manufacture. There was technological advancement in every sector gradually. However, once it started, it went forward. There was and there is still the utilization of fossil fuels, right? To obtain energy, to have electricity, and we started building vehicles. We started using more and more fossil fuels. But what has happened? Of course, population has increased a lot globally. So let's go to the next figure. I would like you to see this one. You see here from 1800s till today, population growth. What takes your attention in this graph? You see that there is 1950, it's like a breaking point, because after that point there is a sharp increase in population. So the rate of increase is really multiplied. This is another reason we need more energy, right? Per capita. We need more food, we need more clothes, we need more of everything. So population growth is one of the main reasons. But what came with it is the usage of fossil fuels. Again, a historical figure from 1800s till today. Find the breaking point, 1950s. Suddenly it increases times for more global fossil fuel consumption, right? Especially coal, oil, and gas. While in 1800s it was almost close to zero, in 2024 we are reaching 140,000 terawatts. So, and today we are talking about renewable energy. So I would like to show you, even today, the majority of energy is coming from fossil fuels. You can find there little rates of solar, wind, and other renewable energy technology, but you see their contribution in comparison to the traditional sources, which are responsible for the most CO2 emissions. Okay, let's go to the next one. So, we populated a lot, we are using a lot of energy. If you are curious how much CO2 we are emitting per capita, per person, it had a trend like this. As you see in 1750, 1800s, 1850, it is almost close to zero, and then it suddenly increases, and we are reaching 5 tons per capita CO2 emitted. I mean, data speaks for itself, right? Just looking in this graph, you can see there is a trend. Whatever this figure is representing, there is a huge upwards trend raising. Here, a figure from Hadley Center. Well, follow the red line because that is the average, then there are the upper and the lower bound, but follow the red line. You see that while 1850s till 1950 there was temperature increase about half degree Celsius. It was at least maintained all that time, a century. And then from 1950 till today, less than a century, we have 1 degree Celsius more temperature increase. And in total, 1.5 degrees more in the last century. Well, a century and a half, right? So, just to show you that this figure is legit, let's compare it with other figures, other sources. So here there are 4 different sources: NASA, Hadley Center, NOAA, and Berkeley Earth. You see that the general trend, the general shape of the figure is coinciding. So 1.5 degrees temperature increase is proven. Well, we don't need to prove it because we know all the inputs population, fossil fuel consumption, etc. Okay, so what about the sectors? Which sectors are contributing and how much? So let's have a look at this graph. Of course, energy is responsible for the majority of greenhouse gas emissions. 73% of the greenhouse gas emissions are coming either from energy use in industry or in transportation or in buildings. So the majority of between these three is coming from industry with 24%. That's why it's very important for businesses, for companies to pay attention their consumption of the energy and emission of carbon dioxide. That's why it's very important to have net zero goals, science-based targets, and have initiatives and programs to fight this. And not only industry, of course, transportation and buildings, all of us, individuals, governments, we are all responsible to decrease our footprint. And do not forget everything, agriculture, forestry, land use, they are responsible too. Around 18% of the overall emissions. There are industries like cement and chemicals which are heavily depending on energy, so they are responsible another 5%. So if some of you are thinking 1.5 degrees, what's the big deal? Well, it is a big deal because our planet is on a fine equilibrium. Although it has some buffering capacity and it can still absorb some more CO2 if we let it alone, such as if we didn't cause deforestation, right? If we didn't cut trees, change the land cover, intensify agriculture, it still had some buffering capacity, but it wouldn't be enough with the levels that we emitted, right? We really emitted a lot of CO2. And keep in mind that there are also oceans. I mean, majority of Earth's surface is covered by oceans. And oceans are another sink for carbon dioxide. So the carbon dioxide in the atmosphere being absorbed in the ocean, in the water, and it gets into the carbon cycle, right? However, imagine we are out of the balance. I mean, too much carbon dioxide is out there and it is being absorbed too much. So it changes the ecology and chemistry of oceans. That is, we have a phenomena going on, ocean acidification. That is because of too much carbon dioxide. It impacts also the marine species, such as their migration trends, etc. So this is really not good for the equilibrium of our planet, and we are seeing the consequences as extreme weather events. Now, I started talking about oceans. Let me tell you, let me give you some more details about the weather patterns, because oceans are responsible to drive the weather patterns, right? So the temperature above ocean in the atmosphere is very important because it is causing evaporation, not only on the surface of ocean, also on the land. So if you think about the water cycle, it is all about evaporation and precipitation. And if we have more temperature, if it is hotter, we have more evaporation. And always think like this. When somewhere on Earth there is more evaporation, there are going to be more rain somewhere else in the Earth because it is the water cycle. And when I said oceans are the climate regulators, they are so because they are driving this weather pattern. They are playing a huge role in the water cycle. So when evaporation happens, it renders the surface water saltier. Saltier the water, higher the density. So density of water affects the movement of water masses. ultimately it is impacting on ocean currents, which are actually forming the precipitation patterns, right? Ocean water going from equator to the poles and coming back from poles to the tropical areas, bringing precipitation there and vice versa. So that imagine that there is this great equilibrium, and then slowly there is a changing trend in one of the variable, which has an impact in the other mechanism, so that more temperature, more evaporation, currents are changing, and with the currents, where will be the rain? The intensity of rain, timing of rain will be changing, or vice versa, lack of rain, so prolonged droughts or short or long-term droughts, right? So these intensifying weather patterns are actually a consequence of temperatures, essentially. So if you keep this in mind, that it is not just 1.5 degrees, but it is more than that. It is impacting globally all of us, and not only us humans, all living organisms. It is imbalancing our planet. I think it is too selfish of us just to buy products endlessly, unsustainably, use energy unsustainably, use water unsustainably too, because water and energy is impacting each other. We are using energy to obtain water and water to obtain energy, so there is also a correlation there. So in every sense, in every level, on a country level, administrations level, policies, businesses, industries, how much they consume, how much they produce, how much we buy, how much we consume in our buildings and in our private lives, it has an impact. We are all part of the play. We are a brick in the wall. So, as I showed you the graph, that was the partitioning of greenhouse gas emissions by sectors. We are all responsible, and only one party taking action will never solve the problem. It is a mindset that we have to achieve, we have to accept, and we have to start taking actions. Okay, I can talk more and more, and I think I will stop here. I hope it gave you a general picture, a better understanding about the fundamentals of climate change, and I hope you really obtained an awareness, and more awareness, whatever you had before. And thank you for listening. If you liked it, please let me know, and please feel free to comment and reach out. Thanks for listening. Bye for now.